ancient history, software, creating software involved a lot of manual labor. You'd invoke your compilers by hand, run tar on a bunch of compilation products in the command line. And maybe, if you're more sophisticated, you'd create a makefile and sort of handwire all your dependencies and compilation products and everything that goes into a completed piece of software by hand. But yeah, that's a lot of manual labor, you know, stone by stone. So at some point along came the IDE, the Integrated Development Environment, which would give you a lot of ways of editing, formatting, refactoring, and structuring and organizing your code. And in the end, building, running, testing, debugging, packaging, deploying, all at the click of a button. Now, I'm Justin. I work on such an IDE, the Scala plugin for IntelliJ. Just out of interest, who of you uses this fine piece of software? Thank you. Thank you. By the way, who knows we're on GitHub, like our software is open source? That's 2. So next time all of you raise your hands, you can actually contribute to this with source code, but also by just reporting bugs, if that's more your kind of thing. So what I want to talk about is integrating developer experiences, namely how to integrate specifically build tools into IntelliJ more flexibly and in a better way than we've been doing so far. And this is done with a build server protocol, in short BSP. And I'm going to give you some specifics on how this protocol works and how it's implemented in IntelliJ. But first, step back. So we've had manual tools on the command line. We've had an IDE, which integrates everything. But yeah, increasingly, we've been working more again with one-tool jobs, like one-job tools that you can run on the command line in a variety of contexts, like on also from the IDE, from the command line, from a CI server tool. Because the way the IDE does it maybe doesn't fit your workflow the way you want to run it on the CI. So in the end, you end up running a simple command line tool one way or another. But what about our general purpose front end? We still want to use that, right? So classically, we've tried to integrate these tools manually one by one into the IDE. But you see there's maybe a little interface mismatch going on here. So you have a lot of friction getting things to work together. There's idiosyncratic configuration APIs. You might have to context switch between command line and IDE. You need to know 2 different interfaces in the end, or more if you use a web front end for the CI. But still, we've done this for a bunch of tools like Scala test specs for SBT specifically as a build tool in the Scala plugin, for a bunch of frameworks like Akka, Play, Scala, FMT, and other tools like Bloop. Have you heard about Bloop? Yeah, that's quite a few. Yeah, Bloop in the end integrates with build tools, and it has exactly the same kind of challenge. So build tools in Scala specifically are a fun story. So many languages have maybe one true build tool, or maybe 2 really popular ones like Maven and Gradle for Java. In Scala, nobody seems entirely happy with what there is evidenced by the fact that we have a new build tool coming out every month or year or so. So we have a lot of choices, little coherence between them. And in the end, you still want to use your favorite editor front end, which is, of course, IntelliJ or maybe one of those others. So yeah, you have these manual steps in the workflow that I mentioned, switching between terminal and IDE because it's not properly integrated. So you have this tangle of haphazard integrations that sort of keep parts together. We build custom integrations for some build tools like SBT, but it's still not very coherent. So I've been trying to tying these loose ends of tooling together a bit to make it a little bit easier for you to create a more integrated developer experience. But before I get to the build server protocol, let's look at some prior art. The language server protocol, suspiciously similar named, which has been created by Microsoft to address a similar problem in the editor versus compiler space. So in IntelliJ, what we do mostly is integrate compilers with the IDE one by one for each language, and basically re-implement large parts of the language in the IDE. And most editor tooling support does a similar thing. And the language server protocol defines a standard way for the editor to communicate with a language server, which is basically a JSON RPC front end for the compiler. And this has been a quite successful approach, so successful that people keep asking us if we're going to use it for Scala 3, and answer is like, maybe. But if we were to do this in IntelliJ, we'd lose a lot of the features that we can offer that the standard compiler doesn't really, such as type-aware highlighting, or like giving you detailed type errors and comparing type diffs and so on, so you just get regular strings or whatever the compiler is able to give you. And so that's one of the challenges. Another is like LSP doesn't really model the structure of a build of a code base, so we have a bit more to contend with on the IDE side. Now, I mentioned various build tools. Let's take, for instance, the new build tool emerging from the desert sands called Fury, which has been worked on for quite a while now, actually, and maybe it will be released here or maybe sometime soon. So right now it doesn't really have a big user base, basically a few developers. So if I wanted to support it, of course I want to support all the build tools, but I can't really justify investing the time into this specific one most of the time. And so another option is that the author of the build tool, John, pretty contributes the support for IntelliJ, but like he doesn't even use IntelliJ, so he's not very motivated, but maybe his users are. But anyway, I just want to support Fury projects in IntelliJ. So what I can do is go here. And oh, I just opened the Fury project in IntelliJ. So how did I do this? I implemented the build server protocol in IntelliJ, in Fury and IntelliJ. So Fury is a build server protocol server. And I would show you around a bit, but it's a bit impractical with this setup. So anyway, Yeah, I was a bit inspired by a quote by Abraham Lincoln, or maybe it's made up. He said, "Give me 6 hours to fell a tree, and it will spend 4 hours sharpening the axe." And I said, yeah, give me 1 month to support a build tool, and I will spend the first year developing a protocol. Yeah, and there you go. So, the build server protocol. Yeah, it sort of extends or complements LSP. It's also a JSON RPC protocol, and it aims at integrating build tools and IDEs, or also language servers. So potentially you could have a setup where the IDE or editor talks with a language server by LSP, and the language server talks with a build tool. And that's actually what happens with metals, if you're familiar with that. So unlike LSP, BSP has a project model that it can communicate to its clients, and also a few generic concepts like build, test, run. So to give a common language to talk about these very simple, basic actions you can do on a build. So these generic concepts don't necessarily map perfectly to each tool, but I think they're regular enough that you can use them in most places. A client or server also doesn't need to support all of them, so it's potentially enough to just support import or build. You don't have to do testing and running. You can still do that on the command line if you're a lazy implementer. So like LSP, it's a client-server JSON RPC protocol with a small specialty that it's sort of bidirectional, while the client attaches to a server. And usually also is responsible for starting the server. Either side can send requests to the other, or also notification. Though typically it's the client that sends requests and the server that sends notifications. Notifications here just mean informational bits that get sent one side and don't expect an answer. One thing we address that LSP doesn't is finding that there is a server available that we can connect to. So in LSP, you need a server-specific implementation in your client. With BSP, that's not strictly necessary, because we say, okay, a server just drops a configuration file into your project or into your user space, and the client can find that at specific locations. And this file just tells you, hey, here's how to start a BSP server and how to talk to it. So, and usually that's just a standard in, standard out protocol. So very simple, generic system. And that allows you to write a BSP server and immediately import stuff into IntelliJ without we on IntelliJ side having to do any support for your build tool. Now one major part is the build structure that I mentioned. So there's a bunch of requests that you can support, namely build targets. And a target is like abstraction for a bunch of information about sources or how to compile something. So it has capabilities such as you can compile this target, you can test this, some language-specific data such as this target should be compiled as Scala files, as Scala, and dependencies on other targets. So basically, with that, you can model some directed acyclic graph. And of course, you can have sources associated with some target. This is a separate request because the sources can be associated with multiple targets, or likewise one target can be associated with multiple sources. There's a bunch of actions you can do that I mentioned, such as compile, test, and run. So the way this typically happens is, you set off a build target compile request with a bunch of targets that you want to compile. The build server will hopefully compile it successfully and eventually deliver a compile result. On the way there, you can get a bunch of notifications from the build server. It will send the notifications to the client, and those notifications encompass progress. So I compiled 120 of 1,500 files, I compiled 200 files, and so on. And diagnostics, that's the word we use for informational and error messages. So yeah, errors, warnings, and connected to a specific code location. LSP has exactly the same system, so a language server can just push through diagnostics from BSP to an LSP client. The progress notifications, we call them tasks. They're also simple. There will be a task start notification, which is, for example, I started compiling this target, and then you get a bunch of updates and eventually a task finish notification. So I want to show you a bit how this works in IntelliJ Scala plugin. So I open Fury over here. Now this is hard to do. Can someone hold my laptop, please? I'll just close Fury over here because it was kind of broken. I'll open Akka. Come on. Yeah, I should have done that, right? So I can trigger a build in Akka, and you'll see here a bunch of progress notifications and how long they took, and a bunch of warnings or errors of stuff, compile errors. So, thank you. And what's useful about that is you see where potential bottlenecks are. So you see this Akka stream, it's already taking 40 seconds. Akka actor test is taking over 40 seconds to compile. So you can find which module, which target actually is taking the bulk of your compile time easily. And this is available already in 2019-2 as an official feature. Next week or so, we're releasing the 2019-3 version of IntelliJ, and it will include some general improvements for the BSP support as well to make it more stable and usable. So you can use it with a bunch of build tools already. However, currently it only really supports Scala targets well. Now, talking about targets, so we've got a few challenges mapping targets to modules. So in IntelliJ, we have the concept of modules, which are kind of similar to targets in BSP. They're also kind of similar to projects in SBT, kind of similar to targets in Bazel, and so on. But they're all like subtly different. So but as an example, let's take SBT projects. They are usually divided into several scopes: compile, test, integration test, and so on. Generally, you might only want to be using compile and test because the other stuff makes the builds too complicated. So instead of different scopes, you'll just use separate projects. But let's take a SBT project with a compile and test scope. Now, BSP doesn't have scopes, so what we're going to do is, when mapping this to BSP, for example, when exporting to Bloop, you'll create a separate target for compile and for test, but they're linked via their base directory, for instance. And then we have another challenge. SBT and BSP support shared sources. So sources that can be compiled under the context of different projects or targets. That's typically the case when you cross-compile against Scala.js, Scala Native, and JVM, or to different versions of Scala. Now, IntelliJ modules don't support shared sources, but they do support scopes, but only compile and test scopes. So what we do here is we detect the different compile and test scopes and map them onto the IntelliJ scopes. And for shared sources, we create a synthetic module which contains the shared sources and listed as a dependency of these different other modules that depend on the shared sources. That's a bit problematic because depending on the dependencies of the shared sources, again, of the modules that share the sources, you kind of have to just dump them into one scope, or you need some way of switching it. So that often might break your highlighting in IntelliJ if you've been wondering why cross-compile projects don't work that well. We're figuring out alternative ways of doing it, but for now we have to kind of live with this workaround. So, short look at the BSP ecosystem. So as client implementations, we have IntelliJ and Metals. Metals is a language server that you can use from VS Code, for instance. And as servers, we have Bloop as the primary implementation, which in turn isn't an entire build tool, but instead it tries to act as a compile server for different build tools. But what you can do with different build tools such as Maven, Gradle, SBT, Pants, and Mill, you export their builds to a Bloop build, and then you can import that Bloop build into IntelliJ or into Metals. Fury is a little special because it is both a BSP client and BSP server. So it uses Bloop as its compilation server, but adds a bunch of build tool things on top of that. So towards Bloop, it's a client, and towards IntelliJ, for instance, it's a server. And then here in the lower right corner, we have Basil and Pants, which are currently also developing dedicated BSP support. So you might already be able to use it if you hack around a bit. Let's have a quick look at the further development of BSP. So protocol version 2.0 final is pretty much done. We haven't changed much in the past months. As you saw, we have IntelliJ, Bloop, Fury, Mill, all building on this version to support BSP. And what we're looking at currently is to support BSP with the IntelliJ platform distribution, so having it as a kind of a core plugin. But that would entail, of course, supporting more languages besides Scala, such as obviously Java, Kotlin. I've also seen some Swift developers looking into supporting BSP on server and maybe client side for better integrating their build tools. And if we want to look a bit beyond BSP, beyond what we have right now, obviously, yeah, we want to think about integrating more tools with standard protocols maybe. So, like, we have to think about what would it take to integrate various linters. Should they be integrated in a build tool, or should they also support BSP? Is this some kind of in-between part? And yeah, remote building is very interesting. And yeah, maybe more fine-grained testing support, though BSP is already pretty good at that, but maybe we want to be able to support testing of individual tests, so have some standard way of addressing individual tests. The way this is done in SBT and IntelliJ currently is pretty hacky and very dependent on specific testing tools. And if you have more ideas, I'd be interested in hearing them. Ignore the Slido part, that was for the last conference. Now, yeah, obviously one challenge with creating a protocol is, yeah, are the tools similar enough to warrant an actual protocol, all this coordination work on a protocol? But the big part is adoption. So, you know, the old XKCD, you have 14 competing standards. Add another one, you have 15 competing standards. So right now I'm just trying to drive the adoption a bit. And that's why I'm talking to you. Now, if you're interested in working with BSP in some way or another, please do talk to me. So maybe we can get cooperation going, making another build tool work better with IntelliJ, for instance. So, if you look at the slides later, you've got a bunch of links to the specification, libraries, test kit, and a blog post which basically talks about the same things I talked about today. So, I'm Justin, I'm on Twitter as Ebenwert, and the Scala plugin team is on Twitter as IntelliJ Scala, so you're welcome to follow and tweet at us. And now, please, I'd like some questions or comments. If you don't have any, that's also fine, or if you want to talk to me privately, that's also great. Okay.